Have you ever wished time would slow down or speed up? What seems like science fiction is actually a real phenomenon called time dilation. Time dilation is one of the universe's most fascinating secrets, a concept that bends our understanding of reality. Albert Einstein, a renowned physicist, proposed the theory of relativity, which revolutionized our understanding of time. His groundbreaking idea? Time is not absolute, but is relative. It's not the same for everyone everywhere, but changes depending on speed and gravity. Einstein's theory of relativity comes in two forms, special and general. Special relativity deals with time dilation due to speed. The faster you move through space, the slower time passes for you relative to someone standing still. General relativity, on the other hand, focuses on gravity's effect on time. The stronger the gravitational pull, the slower time runs. Imagine a spaceship traveling at incredibly high speeds, close to the speed of light. According to special relativity, time inside this spaceship would pass slower compared to time on Earth. If we could observe a clock on the spaceship, we'd see it ticking slower than an identical clock on Earth. This isn't an illusion. Time itself is actually being stretched. Gravity, too, plays a role in time dilation. This phenomenon is a key aspect of Einstein's theory of general relativity, which revolutionized our understanding of gravity and the fabric of the universe. Imagine a clock placed in a very strong gravitational field, like near a black hole. The immense gravitational pull of the black hole would cause the clock to tick more slowly, compared to a clock in a weaker gravitational field. Time for this clock would run slower compared to a clock in a weaker gravitational field, such as on Earth. This effect is known as gravitational time dilation, and it has been confirmed by numerous experiments and observations. This is because massive objects warp the fabric of space-time, causing time to slow down in their vicinity. The greater the mass of the object, the more it warps space-time and the more pronounced the time dilation effect becomes. This warping of space-time is what we perceive as gravity. On Earth, we experience this warping of space-time as the force of gravity that keeps us grounded. However, near extremely massive objects like black holes, this effect becomes much more noticeable. The closer you get to the black hole, the stronger the gravitational field and the slower time moves. For astronauts traveling near a black hole, time would pass differently compared to those on Earth. If they were to return, they would find that much more time had passed on Earth than for them. This fascinating consequence of general relativity shows just how interconnected time and gravity are. Einstein's theory of general relativity has provided us with a deeper understanding of the universe, revealing the intricate dance between time, space, and gravity. It continues to be a cornerstone of modern physics, guiding our exploration of the cosmos. Time dilation isn't just a theoretical concept, it has real-world implications. This fascinating phenomenon, predicted by Einstein's theory of relativity, affects everything from the technology we use daily to the lives of astronauts in space. When we talk about time dilation, we're referring to the difference in the elapsed time as measured by two observers, either due to a relative velocity between them or a difference in gravitational potential. For instance, GPS satellites orbiting Earth experience time dilation due to their speed and altitude. These satellites travel at speeds of about 14,000 kilometers per hour and orbit at an altitude of approximately 20,200 kilometers. At these speeds and altitudes, the effects of both special and general relativity come into play. Special relativity tells us that the faster an object moves, the slower time passes for it relative to a stationary observer. General relativity, on the other hand, tells us that the stronger the gravitational field, the slower time passes. Engineers make adjustments for these tiny time differences to ensure accurate location tracking on our devices. Without these corrections, the GPS system would quickly become inaccurate, leading to errors of up to 10 kilometers per day. This is because the clocks on the satellites, which are affected by time dilation, would not be synchronized with the clocks on Earth. By accounting for the effects of relativity, engineers can ensure that the GPS system remains precise, allowing us to navigate with confidence whether we're driving in a city or hiking in the wilderness. Similarly, astronauts aboard the International Space Station age slightly slower than people on Earth due to their high orbital speed, although the difference is minuscule. The ISS orbits Earth at a speed of about 28,000 kilometers per hour, which means that time passes a bit more slowly for the astronauts on board compared to people on the ground. Over the course of a year, this difference amounts to just a few milliseconds. While this might seem insignificant, it is a real-world demonstration of the principles of relativity. These tiny differences in time can have important implications for long-duration space travel and our understanding of the universe. As we continue to explore space and develop new technologies, the effects of time dilation will remain a crucial consideration. Time dilation has profound implications for future space travel, especially for interstellar journeys. If we can achieve speeds closer to the speed of light, time dilation could allow astronauts to travel vast distances within their lifetimes, even though thousands of years might pass on Earth. This concept opens up exciting possibilities for exploring the cosmos and potentially even encountering other civilizations. Time dilation is a mind-boggling concept that challenges our everyday understanding of the universe. Imagine standing on Earth, watching the seconds tick by on a clock. Now, picture an astronaut traveling at near-light speed, experiencing time at a different rate. This phenomenon, predicted by Einstein's theory of relativity, shows us that time is not as constant as we once believed. It's a reminder that the cosmos is full of mysteries waiting to be unraveled. The idea that time can stretch and compress depending on speed and gravity is both fascinating and perplexing. It forces us to rethink our perceptions of reality and our place within the universe. As we delve deeper into the study of time dilation, we uncover more questions than answers, each one more intriguing than the last. It reminds us that the cosmos is full of mysteries waiting to be unraveled. The night sky, with its twinkling stars and distant galaxies, is a vast expanse of unknowns. Each star we see is a beacon of curiosity, urging us to explore further and understand more. The universe is a grand puzzle, and every piece we find brings us closer to seeing the bigger picture. As we continue to explore the universe, we are likely to encounter even more bizarre and fascinating phenomena. From black holes that warp space and time to the possibility of parallel universes, the potential discoveries are endless. Each mission into space, each new telescope, and each scientific breakthrough brings us one step closer to unlocking the secrets of the cosmos. We are likely to encounter even more bizarre and fascinating phenomena that will further expand our understanding of time, space, and the very fabric of reality. The more we learn, the more we realize how much there is still to discover. Our quest for knowledge is a never-ending journey, driven by our innate curiosity and desire to understand the world around us. That will further expand our understanding of time, space, and the very fabric of reality. So keep questioning, keep exploring, and never stop being curious about the universe and its secrets. Every question we ask, every experiment we conduct, and every observation we make brings us closer to the truth. The universe is vast and full of wonders, and it's up to us to uncover them. And never stop being curious about the universe and its secrets. Curiosity is the driving force behind all scientific discovery. It's what pushes us to look beyond the horizon, to question the status quo, and to seek out new knowledge. So keep exploring, keep asking questions, and never lose your sense of wonder. The universe is waiting for you.